When identifying minerals, one of the most difficult characteristics to look at is going to be its mineral cleavage. So let's look at cleavage together and talk about what it is and how we identify it. So cleavage just represents the planes that are generated when the mineral naturally breaks. So not all bonds are equal in strength. Some bonds between elements are stronger, some are weaker, so it tends to break along those weaker planes. And so when it does that, it leaves these stronger planes that are all intact, and that forms this flat surface that we call cleavage. So let's take a look at some ways of counting these number of planes, because often it'll say, you know, how many planes of cleavage does this mineral have? And so one simple example that can be a little tricky, but I'm going to hopefully clarify that for you right now, is when you have a really flat mineral. And so I'll actually show that to you right now. So it would be something like this. So if you can see that, it's really thin and it's got these two flat surfaces, almost like a piece of paper. Okay, so that's what I'm trying to draw here. And oftentimes people will look at that and say, oh, it has two planes of cleavage. It has a top surface and a bottom surface, but really that's the same plane. It's all in the same orientation. And so you could continue to kind of slice that mineral and generate more and more, flat surfaces. So since it's all in one direction, we would say that this is one cleavage plane. So when we're looking at minerals, we actually want to find the set or the pair if we can. Sometimes the backside is missing, that's okay, but you know that it would be there if the mineral hadn't broken off or something like that. So this is one cleavage plane. And then let's take another example that's a pretty common or easy one to look at. And I'm going to draw a cube here. Okay, so it would be like a die, if you're familiar with that. And so if you think about it, a die has 6 sides, right? 1, 2, 3, 4, 5, 6. But really, we don't want to count all 6 of those. We want to look for the planes or the sets of cleavage. And so you would have a front and back pairing, a side and side pairing, and then a top and bottom pairing. So this actually has 3 planes of cleavage. And so I have an example of that as well. And it's in this one right here. So hopefully you can see that. I can actually put my fingers on the top and bottom, the front and back, and then side to side. And so this really is forming kind of like a cube, just like I've drawn on the board here. And what you'll notice about this one, if you can see it, is that these are at 90 degrees. They're at right angles to one another. And so I've drawn that in this example as well. Since this is at 90 degrees, we would say 3 at 90 degrees. Now, that's not always the case. There's another really common mineral that you'll learn about in this lab where the angles are actually off of 90 degrees. So some are kind of like this, where they're an acute angle, and then some are laid back, so they're an obtuse angle. And so I have an example of that as well. It's not as easy to see, but this mineral has the 3 planes as well. There's a top and bottom, a front and back, and then a side to side. But if you were to look at this closely, you would see that they're actually at an angle. And so you'll get something likely like this in your lab kit. So be looking for that. So we would say that it's 3, but not at 90 degrees. So you would make that adjustment when you were writing down the characteristics of that. One other thing I wanted to talk about is that this particular mineral has 2 planes of cleavage, which you'll get something like that in your lab kit as well. But sometimes it's really difficult to know, like, I've kind of got this semi-flat surface, but it's not completely flat. So is it really cleavage or not? And so one of the things that you can do is you want to face some kind of light source. It can be a natural light or just a light from a lamp. And you want to kind of rotate that mineral toward that light. And what'll happen is, even if the surface is uneven, at one point, the light is going to hit all of those kind of uneven surfaces at the same time. So like if the surface happens to be kind of like this, so it doesn't look totally flat. But what will happen is, when you orient it correctly, all of all of these flat surfaces will hit at the same time. And so the light will kind of bounce off of it and you'll see a flash. And so I can do that with this mineral, which again, you won't be able to see, but when I rotate it, like, oh, there's the flash. And I can see that even though it's not perfectly flat, this is a cleavage plane because I'm getting all those atoms lined up and the light's bouncing off all at once. So hopefully that was helpful and will get you pointed in the right direction.